outside.
So if I do,
This is very strange because I don't know whether other people can see your screen.
this one, right? And then,
But this is going to be a problem because last time somebody did this possibility.
oh, really?
So remove that presenter view. Just a normal.
Minor show.
Almost.
I'll get my laptop and check it out. There's no way of knowing whether other people can see.
No, I changed back to the minor, so it should be fine. Yeah. Nobody will be here.
It was interesting.
In here for a long time. I didn't see it. I do not know whether it was right or not.
他说不能 minor，他说要 minor 才可以用，所以我要 change，
I'm so like
我要换成 minor，
1.5 months ago. It told me that he
就是荧幕
go back
哦
to
，mirror，
Taiwan. After that,
我要怎么做？
Yeah, yeah.
No, that never.
Camera set.
it worked.
我没有插电啊，
I think last time I know, which is it was
屏
working.
幕关掉怎么换下一页？
我就看那个抖音剪辑，要自动连那个，
Yeah, and
哪个？
我觉得我手机抖音。
For some reason, I didn't get the mail.
六页而已，
学习嘛，
又来了，
哎，
哎，哦，有吧？六页，10分钟内把它。
one that was
啊？没那么多，一直重复做，哪有那么多数据？都做一样的东西，没有什么好放的。
actually, it's only the other.
So there's going to be just us, I think.
What?
Dr. Sarvanan is not allowed.
Yeah, I know Sarwana is not here. Pin is not here. You guys probably the only one.
Yeah.
So 10 slide would be better, right?
Just takes.
Who's Jesse? Where is Jesse?
Jesse?
Uh-huh.
Jesse will be doing remotely.
Chicago.
Chicago.
Okay. How long will he be there? A week?
He does every,
2 weeks?
2 weeks. 2 weeks, 3 weeks.
He's rich.
Yeah.
He wants to graduate.
Yeah, he wants to graduate this August. Not August, sorry, October.
How many years?
3.5.
It's been pretty quick. Like he came 2012
Yeah.
summer. 2012 summer.
Same to job.
Yeah.
Jason is there.
I don't think we will see this.
I don't think Chris will be here. I mean, online.
How many slides do you have?
I can just say 6 slides.
Can you go to the presentation more? Trying to make sure you can see that.
What the hell?
Yes, meeting.
Nope.
No?
You can see it.
You have to share it, I think. You have to first share the Google.
Which one?
The green, second, third,
This one?
yeah. Choose the correct screen. I mean, you have multiple of them.
Higher.
The last one. No.
This one?
Try that one.
No, I think it will be entire screen.
No. I cannot see the full screen. I am seeing.
I think it's the first.
Yeah,
the
it's
first,
not that
I
one.
think it's the first one.
This should be the first one. Come on. Yeah, there you go.
Now if you start here.
Can you go to the presentation? Yeah, there you go. Sharon is not here, so no quiz. You need to wait for anybody, otherwise you can start.
Oh, okay. Quick start qualification. So that's my first time to present it, my result for 3 years, and I only have like 10 or 15 slides. So enjoying the quick presentation. So the first things before we start the stories, I will give you the introduction why I want to do this and the results I have right now, and then the conclusion. The story is beginning from the ocean simulation models. So in order to run an ocean simulation model, we need to have not only the initial and boundary condition, we also need to have an atmospheric forcing or other forcing files. So basically, in traditional way, we want to have the winds, surface heat flux, and the surface moisture flux. And then for like Ping Li, he want to do, you can also what he want to do is investigate it. I think it's like a river discharge stuff. So you may add the runoff the data set. And if you are interested in wave, you can add wave. But traditional way is just wind, heat flux, and the moisture flux. This plot is showing the heat flux. Where can we get the heat flux data? So for the heat flux data, since 1990s, we can get this kind of different products we can have them. So we have the institute observation system, we have the reanalysis products, we have a remote sensing product, and the branded product. The branded product is they combine the remote sensing data with the reanalysis data, like a CCMP, but this is only for the heat flux. So we have lots of heat flux data set. Which one is the best one? How different and what the difference happens? Right. So we want to see the difference between each other. Fortunately, somebody already did it. So here has 4 different type of heat flux data set. One is the OF flux, a CCP heat flux data set, and the one is the COV2 data set. And the lower right one is the, I should say, the lower left one is the CFSR reanalysis heat flux data set. And the lower right one is the NOC 1.1A, is the Institute observation data set.
Is this a radiative fluxes or a total flux, everything?
Everything, net.
Everything.
Yeah. So basically, you can see the major features of for each product. However, they are
Let's not come up right.
oh, okay. However, not just the major features. The other features is totally different. For example, you can see that this conventional and this conventional is very strong, but in other products is not very strong or maybe weaker than what we thought. Another way to get a heat flux, or the moisture flux, we can use the bulk formula to calculate. And the first one, 5.1 is the moisture flux, and the 5.2 is the heat flux for the in the bulk formula. Both of them contain the U there. The U is the wind products. So if the heat flux is different, we want to see how the wind is different. So if the wind different, the heat flux and the moisture flux were different, of course, because the U comment is U variable is the common one in the bulk formula. And what kinds of the spatial scales has lots of difference? Is it like a mesoscale difference, or is large scale difference, or is like a coastal or tiny small scale difference? And if we do see the difference, what kinds of result we will have from the ocean? Okay. So here is the difference between 6 different type of wind products. The shaded, the color is the wind stress, and the contour is the SST. Basically, you can see the SST in OF flux quarter degree, and then the quick scale quarter degree is almost the same. And the reason why is the OF flux combined lots of satellite information into the renaissance data. So they look the same, and the OA flux 1 degree has the similar pattern. However, since the degree, the resolution, spatial resolution is a little bit close, so you cannot see the final features of it. Compared with the EIA interior, MERA, and the NCEP1, the lower 3 panels are the renaissance data we commonly use, not the NCEP1. But you can see in the EIA interior, you can see either the SST or the wind stress is not as good as we can solve. Like we saw the renaissance data is very good. It's like commonly we say this is the true value, but actually it's not. So this has some difference there. Another thing is if we compare with the MERA with OF flux or the NCEP with OF flux, you can totally see the features of the SST or features of the wind stress is gone. And the stress magnitude is much smaller than the OF flux, even though the resolution is higher than the 1 degree OF flux. So this is the difference between the wind product in mesoscale. Okay.
What about just the average difference? It's like, so it feels like this is for 1-2 weeks, right?
Right.
This is for 1 of the 2 weeks.
Right.
Even what in general how it is, like in general, like
I think it's also different. So here is another thing. Well, not in the Gulf Stream region, but when we coast to the coastal region, we also see the difference. So the difference in the coastal region, we can see if the Q scale data is the true value, SS and MI is another true value, but they have the difference, but like really tiny, small differences. The NOGAPS is the forecast model, and you can see the difference too. EIA 40 and the NCEP2 are the renaissance data. The most of all, the difference is showing along the coastal region.
okay.
Yeah, the reason is because we have a different resolution. So the land sea boundary were different, and then we will contain a different land information to the ocean. That's the reason why you see the difference. And then, so we see the difference. What we want to do, like we see the difference. So right now we want to know how different from in the ocean response from the atmosphere. Here is the paper. He said the tides and the winds are the major component for the magnitude mechanical energy to mix in the ocean. And we have 3 different types of wind effects. The one of them is the wind generated internal waves will change the ocean mixing. And commonly used, we use the equation called wind work to calculate how the quantitative or something. Yeah. So the goal of this report is try to discuss the difference between each wind products in near initial band in the Gulf of Mexico. And then another one is we try to see the ocean response of it. The data we use is we use 6 different type of data sets: CCMP, EIM, period, MERA, NCEP2, NAR, and the NUM. The only thing different is the NUM. NUM is the forecasting model in the North American region. The others is the analysis. The CCMP is combined with the remote sensing data. And before we jump into to talk about these plots, I just want to explain how to read it. The first thing is the red line is the clockwise wind circulation. The blue line is counterclockwise wind circulation. And we have 3 different types of axes. The top axis is the proxy of the inertial frequency in depth. So we say the 30 degrees, its initial frequency is like around 1 day, which is that means. And the lower axis has 2 axes. So upper one is the latitude, which latitude we have which initial frequency. And all of the price along the 90-degree west.
So how do you go to the clockwise and anti-clockwise from U and V bit?
So you go to the FFT, and then you get an exponential I something, right? And the plus one is one way, and the minus one is another way. Yeah. So here is the 6 different type of products of the initial frequency. And obviously you can see the difference. So the first difference is we have 2 peaks in each data set, like this, 2 peaks. But only the NCEP2 doesn't have that. I think this is because the NCEP2 resolution is too low, so they cannot resolve it. The second thing is the local peak is almost around like a 25-degree north to 35-degree north. The third thing is the difference between the CW and CCW. So you can see the totally difference in CCMP and the MERA. Most of all, the CW wind circulation dominate the initial frequency. However, the MERA, the difference is so weak, so we can say it's almost equal to each other. And we think this difference, the initial energy, is coming from the Lancy breeze. Since in latitude, okay.
Could you also just refresh? So what is this inertial energy, inertial frequency? You're talking about something inertial oscillation or something.
Right.
Can you just remind me? I'm not able to. What is inertial oscillation?
How did you divide it?
Inertial is the period of
There is
24-hour period, right? That's what inertial
No,
means.
it's a balance between this, or is it a balance? Means why is this important? Why is inertial energy important? Why are we looking only at this frequency?
If you go back to the, it's talking about the wind generated internal wave. So part of the internal wave is caused by the initial, so it's just the F.
Okay.
For example, if we have eggplant pumping, we have the shallow water equation with the wind stress over the H, right? And over F of H to get the solution. So F is very important in each.
Okay.
Yeah. And we think the lengthy breeze has this, since the lengthy breeze, its period is like 24 hours, it's like 1 day. So in the regions of the Gulf of Mexico, it's very important. So the plot here shows you the diurnal frequency map. The black line, above the black line is mean the diurnal frequency is in the near initial frequency region, in the near initial band. If the lower the black line is mean the diurnal frequency is out of the near initial band. And since we think the near initial band is very important for the ocean mixing, so if we're out of that, we probably didn't care about it. Okay. So the most things you can see is you get a maxima peaks in the Yucatan Shelf. This area, Yucatan Shelf, in each of products, but the magnitude is different. Another thing is the local peak. This is the local peak. Those local peak are very important because it's above the light. So we say we can image that if we have lots of light, then we probably will enhance the near initial frequency. So jump into the near initial frequency map. So the boxes still represent the local peaks in the diurnal frequency. And then you see in the near initial frequency map, you see the enhancement. So that's the reason why people keep thinking about the Arizona effect in the Gulf of Mexico, because we have very strong near initial frequency there. And then this kind of near initial frequency energy is associated with the length breeze diurnals. So right now we're only talking about the reanalysis data, but we want to compare with the observation data. But for the Gulf of Mexico, you only have a few points to measurement to have the wind products, wind information. So how to represent that is kind of important things in the near initial band. So we use the harmonic analysis first to filter all of the information, and only we want to have the near initial band information. And then we construct that as a wind ellipse. So since we only filter we directly filtered out the information. So the wind ellipse here, we have the CW signal and the CCW signal. However, when we plot it, all of the ellipse is clockwise, which means the CW signal dominates the lengthy breeze. Besides, if the ellipse is approached to the circle, which means the U component and the V component are quite important. And if the ellipse is approached to a line, which means either the V component or either the U component is important. So I just want to say this one is here. So jump to the comparison. The first one is in the northwestern Gulf of Mexico. The size of the ellipse and the shape of the ellipse look the same from the observation data to the reanalysis data. The most important part is this part. The reason why we care about this part is this research is previous research to investigate oil spill, BP oil spill site. And since we think the near initial frequency energy is the most important one to the vertical missing in the ocean. So this part is very important, okay? And then you can see in the observation data, the energy is much stronger than the reanalysis data and the focus data. And then the second thing is either in the central north Gulf of Mexico and the northeast Gulf of Mexico. Okay, what I want to say in this one. Okay, and the direction of the ellipse is the face of the Lindsay breeze. So basically, you can see the direction is almost the same. The face is the same. And if we use those of the tidal wind products, we can calculate the wind work. The wind work is calculated by this one, the wind stress dot the current speed. And here we have 4 different types of wind products: the CCNP, ECNWF, NUM, and the NAR. And then the bugs represent the local peaks of the diurnal frequency. So for that, we can see the very strong wind work in the northeast Gulf of Mexico and the central Gulf of Mexico, central north Gulf of Mexico. And then some part of the central Gulf of Mexico has the strong signal too. And then although we didn't see any near initial, you have a question?
Sorry.
Near initial frequency wind products, we didn't see anything in the Yucatan Shelf, but we can still see the wind work there.
Speed of water, speed of the wind.
Wind stress times
Times
the
the
current.
speed of current.
Yeah.
Current. So that should be negative.
Dot. Is
Is it vector dot?
vector dot or vector.
Yeah, I think that should be negative value of work, right?
Why is it negative?
Supposing that stress is in the opposite direction of the ocean current.
If it's, yeah, if it's the,
Okay.
but it is the same direction.
Yeah, oh yeah, I see.
So just very quickly and finish it. So, all right, we didn't see the difference, and the CCNP looks very strong in the near initial energy between the CCW and CW, and the MERA, the signal in signal of CW and CCW in MERA is almost the same, right? And then we also see the resonant effects in the Gulf of Mexico. And then compared with the observation data, the semantic wind is weaker in the near initial frequency band, especially in the central north and the northeastern Gulf of Mexico. So compared with that, if we think the near initial frequency energy is very important for the ocean mixing, and then we already see in the central north Gulf of Mexico, they have a strong signal of the near initial frequency band, then we can image the oil spill situation is not just related to the river discharge buoyancy effect, but also related to the diurnal signal, the Lindsay breeze. That's all. Quick, right? Question? No. Oh, we do have somebody else. So.
Besides that, diagonal signal is in effect, so that you try to eliminate some of the frequency.
We want to see, because we already see lots of references, and say in the north of Gulf of Mexico, we have the resonant effect of in the near initial band, and those are resonant effects is actually from the Lindsay breeze, and which is 24 hours the frequency. We say that's the reason why we say it's a diurnal signal. So for all of the plots we try to make here is we plot the diurnal signal map, and then see whether we can find out the resonant effect in the Gulf of Mexico. And then if we find a resonant effect in the Gulf of Mexico, then how it related to the ocean response. And so that's the reason why we calculate wind work. And right now, from the wind work, we see very strong signal in the Louisiana and the Mississippi Shelf, and that region is also covered the BP oil spill site. So, and then that region also have the Mississippi River discharge. So that site contain the information. If we want to investigate the oil spill forecast model, it's not just that we add the river discharge information into the ocean model, but we also have to have the correct wind products. That's the summary. Yeah.
So from your comparison, which wind product is good?
Right now it's a CCMP, because I mean CCMP is not that good, but at least the energy for the near initial frequency is much stronger than others, especially in the oil spill side. So that's why I said it. Tom?
So you can ask whether there's any questions from remote.
Wei Qing is not here, so but she's online. I don't think you have a question. Who did you have a question?
No. Hi.
Okay, good.
You're forcing people not to ask questions. I have to keep asking questions.
We done?
I'll talk to you later.
Okay.
I guess since I have very basic questions.
Okay.
I still don't understand what inertial frequency. Why is it important?
Oh, okay. Yeah, talk there.
Yeah.
The balance is between the partial peak term and the
And the Coriolis
Coriolis
force.
Yes. That one.
The
The
co-
balance of these two terms generates this.
The balance between Coriolis
Coriolis term and the time rate.
and time rate. Okay.
Yeah. Partial U, partial T.
Okay, that's the balance. So why do these frequencies have a peak here?
That peak area it is because you mean the position of the time frequency, because it is controlled by the Coriolis term, so it is at the peak frequency at f with f, right?
Oh,
it is the
okay.
daily, right?
Okay.
The rotation of the Earth is daily,
Okay.
and it has a peak at the latitude at 30 degrees north. Is because that at the mid latitude it is f is big, right?
Yeah.
Yeah.
Kind of. That's.
Okay. Done.
Don't get
Stop, right?
not that.